before I pass it to her. And Jane will be leading the today's session, and I will be here for her to assist for all of the event. So Jane Waitara is a talented Android engineer and a product designer. She has a strong track record of creating user-centered and visually appealing products. In addition to her professional work, Jane enjoys outdoor activities such as hiking and swimming. They also have a love for podcasts and constantly seeking new knowledge and inspiration through audio content. Jane is not only dedicated to her craft, but also giving back to the community. She is volunteered at Women Who Code and Women Tech Makers, organizations that empower and supports women in tech industry. So she's also a Women Tech Makers ambassador, and I am also a Women Tech Maker ambassador too. So I am now passing it to Jane. So thank you.
Thanks, Selen. Hi, everyone. I'm going to share my screen. Can you see my screen? Okay. Hi, I'm Jane Waitara, as Selen mentioned. I am a product engineer. I'd love to call myself that sometimes because I am an Android engineer and a product designer. And yeah. So in this call, we'll be talking about layouts in Compose. So maybe like a quick starter would be, what we'll talk about is Jetpack Compose. We'll also go through what a composable is and also dive deep into layouts in Jetpack Compose. How many of you know what Jetpack Compose is? Maybe you can type your response in the chat section. Or how many have used Jetpack Compose so far? Melissa says it's a UI library. I have only used XML by Alexandra. Luba says she used it once. Wow, okay. Rufaro has a little experience on this. Thank you so much for engaging. So Jetpack Compose is the new UI toolkit for building native Android applications, and it simplifies and accelerates the UI development process because compared to XML, there is lesser code that the Android engineer would write. So what's a composable? So in Jetpack Compose, we have functions that we annotate as composables, and these are the smallest or the basic building blocks of Compose. And these composables return a unit which describes a part of a user interface. So, and the reason as to why sometimes, like all the time, we don't see the return type as the unit is because in Kotlin, when the return type is unit, we don't necessarily have to show it. But a composable function returns a unit which is part of the user interface. Then, so why are we talking about layouts? So generally, because these composables return a unit which is part of a UI, when you add these composables to your screen, for example, if you're building a home screen and you add them, without specifying how these layouts, these composables will be displayed, by default, Compose stacks them one on top of the other based on which one that you added first. So for that reason, it is required of us to use layouts that specify how we want to render the UI within the screen to make it to match what the product designer has provided or what we are currently building. So some of the layouts that we are going to talk about in this session will be box. We'll also talk about rows and columns, constraint layout, flow layouts, and lazy layouts. There is more layouts that Compose offers, like box with constraints. You can also create your own custom layouts, but because of the interest of time, we'll not get to talk about those others that are there. So we're going to start right away. So these are just simple representations of how the different layouts would look like. So we have a column. So a column allows us to position our items vertically. So if we add 3 composables within a column, they are positioned vertically from top to bottom, while a row positions our items from left to right or left to left horizontally. So the difference between a column and a row is that a column displays data vertically, while a row displays the data horizontally. However, for a box, when you have different items, the items are stacked on top of each other such that the composable or the element that you added as the first item within the box will be at the bottom of the layer, while the element you add, the last one, will be at the top of the box. So if you have added, assuming you add 4 elements within your box, the first element that you added will be at the bottom layer, followed by the second one, the third one, and then the fourth one. So assuming they are all the same size, the only element you will see will be the fourth one. For a constraint layout, this is a layout we use to display elements that are related to each other. So what that means is it helps us to lay our elements in relation to one another. So we're going to see that in Android Studio, and I'm going to be context switching from slides to Android Studio. I hope that will not be confusing for you. And also in this presentation, we are going to be creating the Spotify Android app. So it's more of the layouts that we're going to learn the layouts based on what Spotify offers us, or it will be just an inspiration for us. So we're going to start with a box. So when you go to your Spotify app on Android, the first thing you see is, hey, a good morning or good evening, depending on the time. Then they usually filters. They're not usually laid out like this, but this is for experimental purposes. They usually, you can see, maybe you can filter by music or podcast. Then there's usually your shows section, new episodes, followed by other items going downwards. So we're going to recreate these with the different layouts that you're going to learn in this session. So we are going to start with the filter section, that one that you can filter whether music or podcast. So how would we create this item? This is how it looks like on my phone. I'm using an Android device. So because it's just one item, I would use a box and then put the text within the box. Then for a box, it usually accepts different parameters, and one of them is a modifier. And modifiers are things that help you style some of these layouts that you have. So in this example, we have used a background extension function of the modifier, which allows us to customize the colors and also the shape of this element. We have also added a padding within this box. As we mentioned, a box is a layout in which elements, its children, are laid on top of one another. So if we had another item below this text, it would be automatically positioned on top of this text. And we're going to see that in this example. So this item is what you see when you go to the search screen of Spotify. There's usually a search field section. I didn't get to add that one. Then followed by this browse all section. So we are going to recreate these. How would we create these? Using a box. So this item has a text. Then we can see it has a background color and also some image. So we define our box and then our modifier. So we have a fixed width and size of this box. That's why we have 160 and then 136. Then we also add a background color because based on Spotify's UI, it has different colors on these sections. So that's what we're doing here. What we're doing here is we have predefined random colors in a list, and then in this composable, we're just picking a random color. Then clip, we are using clip modifier. It helps us add the shapes to this box. Then within the box, we have added children, which the first one is a text, which will be this, that will symbolize or just show the category of what we want to search by. Then we also have an image, so I've added that image within a card. So as we can see, we have changed within this card, assuming we did not have any of these modifier extension functions that we have added. Ideally, the image would be positioned on top of this text. We can just test that right now. So if let's just see how the box, without adding any of these styling elements, the card is supposed to be positioned on top of this text. It's still loading. Just give it a moment. The reason as to why the colors are changing is because every time it recomposes, it gets another random color. So don't worry about that. Then there is another way we can see this is because in Compose, we can preview the composables that we have created. So in this case, we use a preview annotation and also define, we have to tell the Compose compiler that this is a composable. Then we call the composable that we have created here. So yeah, so without the styling, as you can see, the text being the first element that we added to this box, it's positioned as the first layer, then the image or this card image comes immediately on top of the text. So returning our elements that we have added. So to change some of the positions of these elements, modifier offers us an alignment extension function that you can change, that can help you to change the position of these items. And this alignment, how you call it, is modifier.align. Then within it, it accepts an alignment parameter, which we call as like this. And some of these things, so sometimes you don't even remember what these things do. So what I do is Control B and go to the definition of these and see, yeah, this interface, the alignment interface offers us different options in which we can choose from. So in our case, we're using bottom end because we want it to be positioned at this end. So the start is usually this end, then end is this how are this called, this edge, then the top is this edge, the bottom is this edge. So if we wanted it to be positioned at this corner, we would say bottom, it's at the bottom. However, between these bottom start, bottom center, bottom end. So if we wanted it to be this corner, we would use bottom start. So as it loads, so some of these things you don't remember every other time. So you can just Control B to where they are defined and get to read, or you can just experiment and see whether what you're looking for is what you have done. And the advantage is that we have the preview. Don't know why it has. Okay. I think it's taking long because this is bottom center. So yeah. So, but you can play around with these section and see what they offer. Yeah, so that's on a box. Then the other layout is a column and a row. So we're going to look at that. So as we mentioned, a column allows you to position elements vertically. So in this example, we have defined a column that has a text, a spacer, and then it also accepts a composable function within it. And so when you go to the Spotify home screen, as you can see, we have the whole screen, which has this section. I would say maybe the welcome section, it has the filters, it has this other section and this other section. So what we have done here in this section is, when implementing these, we can see that this text and this text have the same styles, and then these content are the only ones that change. So there's something called slots, so where you pre-create a composable. So in this case, if you ignore these elements and these elements, the layout of this item will be the same as the layout of this section. So that's why we have this that takes in the header. So I would refer to this as the section header, and this as the section header, and this as the content. So the content is this that we see here. It's now a different composable based on the content that you want to show in that section. Another example of a column would be the whole of this screen. All these items are positioned vertically, one after the other. So how we did that is we used a column that accepts a modifier and also defines padding. So vertical padding is the top and the bottom padding. Then I'll come to these. Then the column also accepts arrangement. So there are things that arrangements are things that define how your elements will be arranged within a certain layout. And because in a column, data is vertically positioned, that's why we have a vertical arrangement. Then in this, so in this example, we say arrangement is spaced. We are using spaced by, so we are defining all the elements within this column, what will be the spaces between them. So it will be 24 dps. So then within this column, we have a top section, which is this section. Then we have, then we have the categories section. We have your shows and the episodes. So the whole of this screen, we have used a column. Then by default, a column is not scrollable. However, modifier offers us a vertical scroll extension function that can be added to a column to make it scrollable. So how you do that is .vertical scroll, then add this state, remember scroll state. Then for a row, it's the difference between a row and a column is that data in a row is positioned horizontally. So for example, in this section, we can see there's a heading and then 3 icon buttons. Of course, in Spotify, they're not plus, but yeah. So here we have a row. Then within the row, we have this good morning text. We also have the icon, the 3 icons just positioned below, but the row positions them horizontally. And just like the column, a row accepts a modifier, which has different extension functions. Then, so the opposite of column, in a column, we were passing in a vertical arrangement because elements are vertically positioned. However, in a row, because they are horizontally arranged, positioned, so we pass a horizontal arrangement. And sometimes we don't, when I was starting out in Compose, I used to confuse why do we have a vertical arrangement in a column while in a row we have a horizontal arrangement. So, but over time I got to learn So don't stress yourself about that. So the easiest way is when you have anything, or how I do it is when I have any composable, I just Control B to go to where it is defined. And then here I can see that this row accepts a modifier. It also accepts a horizontal arrangement, a vertical alignment, then it accepts a composable function. So then the other thing that we've not talked about is the vertical alignment, is how within this row, how maybe the row is 56 dps, how will your items be positioned vertically? So maybe within the 56 dp, you want them to be at the top, so, or at the center, vertical center, or at the bottom. So this vertical alignment helps you to give those rules. Yeah, so that's on column and rows. Then the other layout that we also have is a constraint layout. And as we mentioned, a constraint layout helps you to add elements that are related, that are positioned in relation to each other. So a good example would be this item. So I called it a show. So when you look at this item, you might think it's a column. You can actually use a column because these elements are positioned vertically, one after the other. However, sometimes you find that this text, you want this text to be as wide as the image. So if the image is 120 dp, so you want this text to take the width of the image. So by default, that becomes a relation to another element, which results to using a constraint layout. If we had resulted to using a column, I had tested these, the text was spanning out of the column bounds, which was forcing the column to be very wide. Hence, the reason as why we are going to force the text to be related to be positioned in relation to the image. And how do we do a constraint? How do we write a constraint layout in Compose? First of all, for a constraint layout, you have to add a different dependency. It has different dependencies, so don't forget about that. That it doesn't come with the Compose UI dependencies. You have to add a constraint layout dependency. So yeah, just a point to note on that. Then after you have added it, it will now be available for you to use. So you define a constraint layout by just calling constraint layout composable. Then, like every other composable within Jetpack Compose, always takes in a modifier. It is also advisable for you when creating your own composables to pass a modifier, because it will help you style your elements. So constraint layout takes in a modifier, and in this modifier, we are adding a fixed width of 120 dps. Then we are saying, because we don't want to have a fixed height, because we don't know how long or how the fixed height of this text, or how many lines this text is going to be. So we are telling this constraint layout, hey, I need your head to be as long as the content that you'll have. So that's why we are using wrap content height. Then if we want this item to be clickable, we add this modifier clickable, then we add these function. Then within a constraint layout, the first thing we do is create references to the different elements that we are going to add in the layout. So that's why we have defined this constraint layout is going to have an image, category, and these are the two texts. Then within each element, these constraint references that we created, we have to add them as constraints. So we are telling this composable, hey, you'll be constrained as this image that is defined within this constraint layout. Then, because we said that in a constraint layout, elements are positioned in relation to one another or to something else within the same constraint layout, this is how we do it. So in this, we are saying this image is constrained as an image, and we want the top of this image to be linked to the parent. And the parent in this case is this mother layout, or because I would say these are children, this is the mom then, so they're the, I don't know why I used mom instead of dad, please, I don't know. So yeah, they are the parent, this constraint layout is the parent, so we want the top of this image to be linked to the top of this layout. And what that means is where the top of the parent starts is where the top of this image starts. However, sometimes you would want to add some padding, that like a small spacing between the parent and the top of this image. So how this link to accepts, to know what it accepts, you can control P to see it accepts an anchor. It can also accept a margin or a gone margin. I'm not sure what a gone margin is, but you can now add a margin. So hey, I want there be a spacing of 16 BP. So that helps you to add that spacing between here. But in our case, we do not want it. So that's also possible. So we are going to do that for every element. So for a text, we are telling it, hey, you're going to be constrained as a category. Then your top will be linked to the image bottom because it is positioned just below this image. However, the start and end of this text should be linked to the start and end of this image. What that means is if we changed the width of this image to maybe 200, the width of this other text will also change to 200 because they start where the image starts and ends where the image ends. If you have used XML, this is the same as the constraint layout within XML. So that's how you do it. There's also chains and guidelines, but you're not going to talk about that. Yeah, feel free to check that out on the documentation. So the other thing that you can add is this width ensures that the text, this text of ours is filling the constraint, because we are constraining the start of this text to the image start and the end to the image end. However, we want this text to fill the whole of this constraint. So that's why we are adding this width. So that's on constraint layout. There's also constraint box with constraint, but I'm not going to talk about that. But yeah, you can check that out as well. So that's on the most basic things that we have in Jetpack Compose. So we have a column, a row, a box, and a constraint. And a small recap is that in a column, elements are positioned vertically. In a row, elements are positioned horizontally. In a box, elements are stacked on top of each other. And then in a constraint layout, elements are positioned in relation to one another or to whatever you have linked it to. So we're going to go and talk about lazy layouts. So in lazy layouts, we have lazy columns, lazy rows, and lazy grids. So what's a lazy column? Like a column, a lazy column also arranges the elements vertically. However, in this case, it is scrollable. If you can remember, I mentioned that a column is not scrollable, while a lazy column is scrollable. The same as a lazy row. Like a row, items are positioned horizontally, but it is scrollable. However, a lazy grid, if you look at these images, a lazy row has just one row going towards the right. In a lazy grid, you can define the number, you can change the number of rows, and also maybe you can change, depending on the width of these elements, the width of these elements will define the number of rows or columns that you can see. So there's lazy vertical grid and lazy horizontal grid. So let's just look at that right now. So let's start with the lazy row, sorry. So in this section we just created this with constraint layout. So we are going to position them in a lazy row because we want this content to be scrollable. Well, for a row, it's not scrollable. Then, so we are going to use a lazy row, and the lazy row, like every other composable, accepts a modifier. Then for a lazy row, it also accepts a horizontal arrangement. So this arrangement is how will our content be arranged within this row, because the data is going to be arranged horizontally. So how do we want it to be spaced, or how do we want it to be positioned? So in our case, we have used spaced by. There are also other different arrangement types. We have space between, we also have space evenly, space around. So just as I mentioned, if you are not sure about everything, you can just go to the documentation and see within there's horizontal and there's vertical arrangement. Then within horizontal or any of these, we have start. So in this start, you position the children at the start, and then they are stacked one after the other. And then if there's space that is going to be left, is going to be left at the end of the layout. Then there's also end, which shows this is the spaces, and then the elements will be positioned at the end. So the last item will start at the end, then it will come towards the left. Then at the top, they will be at the top, and then for horizontal, in most cases, we don't usually use this, but yeah, so then there's the ones that are usually most confusing is space evenly. So if you look at these, the reason that's why I'm showing you this is because in most cases I usually come here to read instead of going back to the web and Google search and then see. So visually it will be like this. When you space evenly, it is going to add spaces. It is going to add like a start space, then the element, depending on how wide this layout is, there'll be spaces in between these elements, and these spaces will be equal from all angles at the center and at the end and at the start. However, for space between, there's not going, the Compose compiler is not going to add a space at the start and at the end. It's going to add the space between, just between the elements, and no space between the last element and the edge of the screen. So it's just the space between elements and no space at the start and no space at the end. Then for space around, it's going to add space both at the start and end of the element. So the first element is going to have a space at the start and at the end. The second element the same. So that's why it looks like the start has one space. So assuming this is 2dp, the space between the first and the second element will be 4, because there's 2 after the first element, and then there's 2 after this at the start of the second element. So it will be 2, 4, 4, 2. Yeah, sometimes it can be confusing, but yeah, over time you get to understand the concept. Then a lazy row also accepts these other things that we have not added. So there's state, there's content padding, there's reverse layout, vertical alignment. As we mentioned, the alignment helps you to align things vertically. So the other thing that we have used here is a content padding. So you might be wondering what's the difference between this padding and content padding. So for normal padding that comes with a modifier, it's a space between, it's this space. I'm hoping you can still see my screen. It's this space between these elements. And by default, when you add a padding, the content is going to be clipped such that the content does not start. This space is just an empty space where the content does not start. However, for the content padding, it's there, the padding is there. How it is only applied, for example, if the content is not clipped. In short, the difference is that the content is not clipped. So in this case, you can see that because there's more content towards the right, you can see that padding on this other side because the content is not clipped. However, for the first and the last items, the content is clipped. So if we were to scroll within this section, when you go to the last item, a moment, you can see that now because we are on the last item, we can see the padding. But on this other end, because there's more content towards the left, we cannot see the padding. Yeah, that's on lazy row. Then for a lazy column, it's the same. However, in this case, the content will be positioned vertically. So for a lazy row, the content is positioned horizontally, but for a lazy column, the content is positioned vertically. Then like in a column, in a row, so in a row, we have horizontal arrangement, but in a lazy column, we would have vertical arrangement because content is positioned vertically. Then for alignment, in a row, we have vertical alignment, but in a lazy column, we would have horizontal alignment. I hope that is not confusing. Then the other thing is horizontal grids. So what you're going to use is this section. If you go to your Spotify app, there's that new episode section that you can see. We have 2 rows of the episodes. So, and the episodes scroll, to scroll like these. So that you might be wondering, why are we not using a row or a lazy row? So if we were to use a lazy row, we would just have this row alone. But for a lazy horizontal grid, you can define the number of rows we want to see. So in this case, we have defined, so a lazy grid, like every other composable, accepts a modifier. Then we have defined the height. Then we have rows. It accepts rows. So in this case, you define how many rows you want to see and you use the grid cell. So you can say grid cell.fixed, then we want to see 2 rows. If we wanted 3 rows, we would have said 3. Then there's also, other than fixed, there's also something called adaptive. So adaptive makes our row to the space available to be divided between the minimum size. So in this case, we want, so for a row, this adaptiveness is the height of the row. So if we want the row to be maybe 48 dps, so what it's going to do is every row will be 48 dp, and depending on the height is 160, it's going to calculate how many rows can fit within this. If every row is 48 dps, how many rows, putting in mind the spaces that we have put in, how many rows are going to fit in this 160. So this adaptive thing is, I can't remember, it's a constructor. It helps a lot when you are building for all form factors. So in that case, if you have like a minimum height of each row, so depending on whether the screen is large or the screen is long or short, or the different form factors, it helps a lot. So in our case, we just want 2. Then the difference between now a grid and just a normal lazy list is that in a grid, we have both horizontal arrangement and vertical arrangement. So what horizontal arrangement does, it's the spaces between this episode and this episode. So this space between here. Then the vertical arrangement is the space between the first row and the second row. So so in our case, we want both of them to be 16 and 16. So that's why we have that. And as we mentioned, we need to add content padding so that our episodes are not clipped over here. Then, yeah, so I forgot to mention. So for both lazy rows and lazy grids, how do we add content? So we use items. If you want to add multiple elements, so you can, so in this item, sometimes you can pass, depending on which one that you have imported, you want to use, you can add either the list or you can add the size. So how we do that is when you type items, you can see we have one that accepts count, one that accepts items, which is an array, then another one that accepts a list. So that's when you want to add multiple elements. However, when you want to add a single element, you can add different items within a lazy row or a lazy column. So if you want to add one item, you just use an item. So when you type item, you can see we have this item and then we have these. So depending on your use case, you can use either. Then there's also something else called a sticky header. And a sticky header is a good example of where a sticky header can be used is on your contact list. When you go to your phone on the contact list app, your contact list is usually vertically positioned, and then there's usually alphabetically. So there's A, B, C, D to Z. So when you get to C, you get to see a C appears at the top. Then D appears at the top just to guide you. Hey, this category is of the people whose names start with a C. So how do you do that? You can add a sticky header. So this one. So even when you have, so assuming we have items, so assuming we have this section, these items one, then we have a sticky header, this one, then we have items. So when we get to scroll, this sticky header will come here, and until we finish scrolling past this content, it will still appear here. And assuming this was a sticky header, when we scroll to get to this point, the sticky header that was here will be replaced with this other sticky header. So that's the use case of a sticky header when you have different elements within your lazy layout. So yeah, just a recap. So of this is a lazy layout is when you want to add a list of items vertically, while a lazy row is when you want to add a list of items horizontally. Then let's see, we're running out of time. Then a lazy grid allows you to define, hey, I want to see 3 number of columns or 2 number of rows. So you might be wondering, while we were starting, you saw that you can make a column scrollable by adding the vertical scroll modifier. So why should I use a lazy column instead of just making the column scrollable? So that's it narrows down to performance. So when you have a very long list, performance-wise, a lazy column would work best compared to a scrollable column, because a lazy column measures items based on those that are coming to the viewport. So while for a column, assuming we have 50 elements, it will measure and compose all those elements and then display. But for a lazy column, if you're scrolling, the composable will be composed as it comes to the view of the user. So yeah, so that's what we get to see here. With a large number of items, a column can cause performance issues because of how it composes those elements, while for a lazy layout, it inflates or measures the views as they become visible to the screen. Then there are things to consider when creating these scrollable items. So it's always advisable to avoid nested components that are scrollable within the same direction. And what that means is, assuming we have created this as a column and we have made it scrollable, then we have a lazy column here. It's advisable because it's not advisable because they are all scrolling towards the same direction. It is going to give us an exception. Then, so how do we solve that? We have, you can have the child have a fixed height such that Compose knows that when they measure these elements, that is a lazy column, it will be of this height such that if you keep scrolling past that height, the column will still be scrollable. It's not going to throw an exception. Then the other thing is, as we have seen in lazy list, you can add several items. So instead of using nested things, you can just have item 1, item 2, item 3 as you go down. So that means the only item that is scrollable is, assuming this was a lazy column, would be the lazy column, and then these items would be its children. So yeah. Then avoid using 0 pixel sized items within a lazy layout, because, or any layout, is because when you use a layout, assuming all these items are, for example, if this column that has the whole screen, all of them are 0 sized, Compose is going, how Compose works is it measures like the parent, and then the parent measures its children's sizes, and then after defining the size, it now then places these elements within the UI. So if when measuring, the height of every element was 0, every item will be placed within the UI. But if after recomposing, the elements now have a different height than before, that means the composable will discard every UI that it had created that had 0, and now render the one that has a defined height all over again. So it will be doing twice, because you had the first time it thought that every item had 0 height. So that's also not encouraged. Yeah, but you can do what works for you. So we have not talked about flow rows, but I don't, in the interest of time, I'm not sure whether we can do that, Selen, but yeah. Hi, Selen.
Yeah, I just missed what you said earlier.
I'm asking, do we have the luxury of time to talk about flow rows and flow columns?
Yeah, I think it is up to you, like, because we are recording this. So if you have time, we can go over them too. And also, like, we are really a bit over time, I think, when you are finished. So our attendees, if also have the time, they can stay and listen. So
Yeah,
you can
maybe. Okay. So yeah, other than these layouts, so the lazy column, the lazy row, the lazy vertical grid, and lazy horizontal grid, we also have flow rows. A while back, they were experimental, they're still experimental APIs, but they were offered by a companies. But as at now, they have been added to Compose. I'm not sure which version it is, but yes, you can find them in Compose UI. So, and what's the difference between a lazy column and a flow row, or a column and a flow row? So if you look at this section of filters, we have our badge, the first badge, all these badges. I'm assuming there are maybe 10. If you look with your, just wanted to say bare eyes, not it's our bare eyes. If just look them simply, they are rows, 3 rows. However, if we were to use a normal row, the content will go out of these bounds. But for a flow row, if they position these items in such a way that if we get to the end of the row, the remaining content will be positioned at the second row, and then if there's more content, it's going to go to the third row. So in this case, we're just using one flow row that has different elements passed to it. And then the flow row, what the flow row does, it measures the width, the available width. Then if the items are so many such that they cannot fit within the first row, the remaining items will be positioned within the second row and the third row going downwards. So by default, they are positioned horizontally, but if they don't fit, instead of going out of the bounds of this container, they will be positioned within the next row and then the other row. So how we do that is all this code will be available. It's available on GitHub. I will share the link in the chat section. So
I shared the link in the chat
okay,
for
thank
the
you.
GitHub. No problem.
I've also added comments that you can read through. Here we used a lazy row, here we used a flow row. So in this explanation, so we say it's a layout that fills items from left to right. And when it runs out of space, so if there's no more space to add the elements, it moves to the next row and positions them as they go downwards. So for this section, our composable is accepting a modifier, then the categories, then so we add a flow row, which also by default, as we mentioned, they accept modifiers. Then we have added this rule, hey, fill the maximum width of this screen. So if the screen was 360.dp, the width of this row would also be 360, assuming we don't have any padding added to the screen. Then, so within this flow row, add a padding of 16 dp horizontally, so the start and the end, and also add a vertical padding of 4, so at the top 4 and then at the bottom 4. Then, so a flow row accepts horizontal arrangement and also accepts vertical arrangement. And what this does, the horizontal arrangement define the space, how the items within the first row will be positioned, within the rows will be positioned, regardless of whether it's the first, the second, or the third. So how is this item, all these items positioned? So as we mentioned, there is space by, there is space between, those that we went through when we were going through the lazy layouts. And at the same time, it accepts the vertical arrangement. So assuming the content does not fit within the first row, by default, it will be positioned at the second and the third and the fourth going downwards. So we also define how these rows will be arranged. So the vertical arrangement is, so in our case, we have said it's arrangement by spaced by. So what that means is, so the first row has these items, then the second has these. So what's the spacing between these, the first row and the second row, is defined by these arrangements that we have defined here. So it's 4 and 4. Then this 4 is defined by this horizontal arrangement. So there are different ways that you can position your items. You can experiment with that. Then within the other layouts, we're using items, but in these, we are taking the list of these categories and saying for each category, render this UI, create this composable, this badge, and then so we pass the category to the badge that you created in the box, in the first item we went through. Then if we go to where this is defined, we can see it accepts, hey, a modifier, it accepts a horizontal arrangement, it accepts vertical arrangement, it accepts a maximum items in each row. So what this does is you can define each row should have 3 elements. Then if we get to 3, just draw the other elements in the next row. So that's what it does. And then it also accepts a composable function. So if we come back to here, I wanted us to experiment with having a maximum. So in our case, we are seeing the first row has 4 elements and then the second has 5. So we wanted to add, hey, we want each row to have 3 elements. So it is going to have 3 elements in each row. Let's see how that is rendered. Yeah. Then as it loads, we can talk about weight modifier. So I think in XML, if you have interacted with XML, there's also this. So what a weight modifier does is, assuming an element has this weight modifier, so what it does is, so in this case, our row has 4 items. So assuming the first item had a weight of 1, that means the floor row is going to measure the available space. And if there's extra space here, for example, in this case, assuming this comedy badge had a weight, what that would do is, every other available space within this row that has not been utilized by anything else, it is going to be added to this comedy. That means it's going to span from where it starts now to the end of the row. So in our case, we would like to add weight modifiers to each of the rows, and let's see how that behaves. Loading over here. Okay. So when we look at this UI, so before we added the weight, if you can remember, each row was, because we had defined, hey, we want 3 items in each row, the first row was reaching maybe around here. But when we added the weight, this remaining space that was from the end to where the row was reaching, so the floor row calculated, hey, we have maybe, assuming we have 96 DPs left, we're going to take those DPs, and because every badge has a weight, we are going to divide this available width of 96 DP with the 3 items in each row, and then add that space that we're going to get to every row. So in the last item, because it's the only item within the list, and there was more space available, it's going to take all that space because it's the only item within the list that has, so meaning it's going to take every other space that was available. So this is helpful, for example, in terms when you want to show maybe hierarchy of items. There are those UIs that you find, hey, the first element is smaller than the second, and maybe the element at the center of the second element, assuming we have 3 elements within a row, is bigger than the others. So what that does is you can pass the weight, this weight modifier, to the second element. Then it takes every other, assuming all after the space is measured, because Compose first measures and then defines this the size of the element and then now places it. When measuring, it's going to see, hey, this comedy, for example, has a width of 96. This has a width of 96, and the whole screen is maybe 360 dps. That means there's more space that is going to be left. And this second element that has this weight modifier is going to take up all that space that was left and keep it to itself. So yeah, that's why this last element has more spacing than everything else, because of the available spaces within the row in which it is in. So the same works for flow columns, but the difference is that it will still have the horizontal and vertical arrangement. However, in this case, the horizontal arrangement will be now the spacing between the columns, while the vertical arrangement will be the spacing between each element within every column. So yeah, that's on flow rows. I hope I've not confused you more. So it is, as at now, it is still an experimental API in Compose, and to get it within Compose, you have to be using, if I'm not wrong, your app needs to be supporting API 34 and above. Yeah, otherwise you can use the accompanied one that will be deprecated when, yeah. So that's on layouts. That's what we had prepared for you for this session. So I'm not sure whether we have any questions. So
we have few questions in the chat, and I just take a note on them. So when you are finished, we can discuss the questions.
Okay, so yeah, but after all, with all this knowledge, there's so many things that you can do. For example, instead of using a constraint layout, you can still use nested rows and columns. You'll still achieve the same thing, but you just do what works for you. So you choose what to do and what to work with. Yeah, and you'll still try to navigate and figure out things depending on your use case. So yep, that's on layouts in Compose. Yeah, thank you for joining and for listening and for actively participating in the chat section. So we can take questions.
Thank you so much, Jane. It was a really insightful session. So we have a few questions. I want to start with the first question. What is the difference between box and card? From Luba.
Okay, so what's the difference between a box and a card? So box is one of the layouts that come with Compose UI. So if you look at these imports, it's actually not Compose UI, it is on the foundation layer. So we have different layers of Compose. We have the foundation layer, we have the UI layer. Then there's another layer that I'm forgetting. Then there is now the design system material design. So a box is a layout that is defined within the foundation layer. However, Google offers an open source design system that is, as at now, it's Material 3 or Material U, and Material U offers a card. So if you go to, can you still see my screen? I hope so.
Yes, we can see your screen.
Yeah, Material 3. So a card is a Material 3 component, I would say, that allows you to they have different types of cards. They have elevated cards, filled cards, outlined card. So if you go to a card, it utilizes the different layouts that we have talked about, but now it has more modifications based on what the design system at Material U defines. So if we go to a card, we can see it uses a surface, and then within the surface, we have a column. So I would say a box is more of the building blocks within the layout, while a card is a composable that you create. Though, as at now, what we have used is created by Material U as one of the components they offer within the design system. So it's, for example, if we decided to create a design system, we would call this a badge, as we have called it. It's a badge. Then if we open source it, people would use this badge. So it's the same as the way Material Design have done it. So they created this component from the different layouts that we have in Compose, then they open sourced it. Did the person get to, did I answer the question?
Tuba, did she answer the question for you?
Yes, thank you. So I was thinking just the difference in appearance, how they look differently. Yeah, now I understand. How do you check? Thank you.
Okay.
Thank you. We have another question from Faye. Which determines the spacing between the good morning text and the 3+ buttons? I think you mentioned that, but maybe we can just go over it again.
The spacing, yes, we can go through that. So this is a row. So the first thing we did was in this row, as we have mentioned on arrangement, we said that we want these elements within this row to be positioned 4 dps apart from each other. So there's space between these and these and these. However, as we have recently talked about the weight, we added a weight on the good morning text such that, so if I remove this weight, you will see that this row is going to reach maybe approximately here, depending on the width of this good morning text. So when we add the weight, good morning text takes up all the other space that is left within this row. So it's going to be this wide, and then this other text will come after. Because as I mentioned, how Compose works is, so in this screen, when we call this screen in the main activity, what it does, it starts to measure, hey, this column, what's your size? And then this column goes to its own children. It measures, hey, the top section is supposed to be this size, the categories are supposed to be this size, and then shows and episodes are supposed to be this size. Then based on those sizes, then I'm going to define my size as the column as this size. Then after they have now defined, so the first step is usually to measure, the second step is to define the size, and then the last step is now to display the elements. So when we come to this row, what it did is it measured the text. So in this case, we don't have a weight. The text width is as far as this text goes. Then we also measure the icon, the size of the icon. All the icons is 24, and they both have a start of 8 dps. So after we have measured that, now this displays, it defines its own size. Then Compose defines the size of this, and then it now displays it. So in this example, they are displayed in this way because the size of this text is as wide as the good morning text goes. So, but when we add a weight, the remaining space that is here is going to be added to this good morning text, and now the text is going to look like it's spanned more. There's space between the good morning text and the icon, but the only trick was to add this weight. Yeah. I hope I answered her question or his question.
Yeah, I think so.
Okay.
Thank you so much, Jane. We have another question from Luba. As I understand, there is no linear or relative layout. Why we have constraint layout?
Sorry?
She said, like, as I understand, there is no linear or relative layout. Why we have a constraint layout
Oh, okay.
in
So
Compose?
in XML, we have linear layout, which you can change orientation to vertical or horizontal. When you come to Compose, the vertical linear layout would be replaced ideally by a column because it displays the items vertically, while the horizontal linear layout will be replaced by a row. While for a constraint layout in XML, it's still the same constraint layout here, now written fully in Kotlin instead of XML. Then for a recycler view, note those options to view, to list. So for recycler view, you can also add grids. So it is replaced by these lazy layouts where we have the lazy column displaying items vertically, the lazy row displaying items horizontally, the lazy vertical grid and lazy horizontal grid displaying items in a grid way. I just remembered, we also have a lazy staggered grid. We did not get to talk about that. But what that does is, so in a grid, all items are the same size. And if they're not the same size, assuming the first column or row has a shorter element, the element would still be aligned the same as the other elements that they are within the same column or row. However, in a staggered grid, every item is positioned regardless of its width, such that they look staggered. Like I think we have a staggered grid in relative layout as well, right? I mean, in recycler view, sorry. If I'm not wrong, we also have in relative.
Yes.
Yes, we have a staggered grid. So that staggered grid in relative layout is what, I mean, recycler view, sorry, is what we have as the lazy staggered grid here. So yeah, to answer your question, so the linear layouts are replaced by the column and the rows. Well, the recycler view is now, we can now use the lazy columns and lazy rows in the grids.
Yes. I think like the Luba has another question in the chat. Also, we answered that, but I just want to like everybody is to also heard that. She asked, lazy is the same as recycler view, as you mentioned earlier. Lazy lists are the Compose equivalent to recycler view, but like as Jane mentioned, like they provide a better performance because they are rendering only the visible items as you scroll through the list. We answered that question in the chat, so I am just passing that. So another question we had from Luba, when we build Compose UI, should we think about nesting? In XML, preferably layout should be as flat as possible to be able to work faster. What about composable UI?
I hope I'm right, but I was researching that, but it says the performance will not be highly affected because of how Compose does. It first measures and then displays it. So it will measure every child of these components. But just for you, why would you nest when you have a constraint layout? But in terms of performance, no, because of how Compose works. It first measures, then defines the size, and then now places the items. So, yeah.
Yes, thank you, Jane. We have another question from Faya. Are all items discussed all native Compose layouts except for the constraint layout? Also, are these layouts all available on the latest stable Android Studio?
I'll take the last question. I did not understand the first question. So are these only available on the latest version of Android Studio? No, because Android Studio is just an IDE that we use to write the code on. However, these layouts are defined by the APIs, the dependencies that we define here. So depending on maybe the Compose UI version that you're using, or Material 3 version that you're using, or even the constraint layouts that you're using, you might get different, how do I say, composables. Some might not be updated. For an example is, for the flow rows and flow columns, you have to switch to, if you're using Compose BOM, you have to use these 2023.08.00 for you to see everything that I have talked about here. So in this version of Compose UI that comes with this Compose BOM version, you can see the flow row has a horizontal arrangement and a vertical arrangement. But if you use a lower version of this Compose BOM, you will not get, it will not have, for this case, the flow row, it will not have a vertical arrangement. It will have, can't remember what exactly we were using on Accompanist, but it will still have some of those. So it's always advisable to sometimes just go through the documentation and see, hey, in this new version, what does it come with? What has been improved and what has not been improved? But to answer the question, it's not the Android Studio. It's these dependency versions.
Okay, thank you so much, Jane. We have another question from Alexandra. Do you have a store color values in a color class, or you still use resource file like colors XML, dimensions XML, strength XML? Like, how do you store the colors in Compose? I think she wants to ask that.
Okay, so when you first create a new Compose app with Android Studio, I think now it has become the default one. So it comes with this theme, which the theme has a color, it has, so in this package, it has theme, it has type that you can change, and then it has color. So this is where we define our colors. So because I was using Spotify's app, technically, that's why we have Spotify green. So this is where we define our colors. Then our typography, we define under this type. So in this case, because we're using Material 3, so that's why we're using their tokens. So these tokens, if you look at these, it's offered by Material 3. So we define, if we are building on Material 3, so in our case, we're building on Material 3, we define our typography, sizes, and line heights and spaces. We define them here. So the color, the shapes, the theme, the type, they are all under, they are not under the resources file folder anymore.
Thank you. I think we have another two questions. Another one from Luba. How do we separate Compose UI description and logic functions?
Okay. How do we separate Compose UI functions and logic functions? So ideally, we would modularize our app, depending on whether you want to modularize by feature, by layer, or by both feature and layer. Then that means, so in my case, because we did not go through all that, so what we did is we created a model class under a different package. So ideally, we would do a data package, a domain one, and a presentation one if we are doing the layer style. So in our data, we would have the model. So that's where we have our data class that has those podcasts. Yes, Selen mentioned I really like podcasts. So yeah. Then that is where we would add our logic code, business logic code. Then under the presentation layer, that is where we would add the UI. So I can if we still have more time, I can maybe build another app. For example, maybe Now in Android. I'm hoping everyone is familiar with Now in Android. It's an open source Google app that showcases how to use Compose. So, but technically, to answer your question, what we would do is either modularize to have our business logic in different modules, or still have everything under the app module, but now have different packages, so that we have the data package, we have the domain package, and then we have the presentation. Then, so under presentation is where we would have our composables. The only difference between the UI and the other functions is that these UI functions have this composable annotation. So the compiler is going to know, hey, it's a UI because it's emitting a unit, which, as we mentioned, it is part of the UI. So yeah, did the person understand what I said, or should I still show the Now in Android app?
Luba, did she answer your question?
I think yes. So this is more like MVVM MVVM structure, right?
Yeah.
Like we have view model, we have model like data source, right? And the UI we describe, the Compose UI we describe in different class, right?
Yes. So let me share my screen. So if you look at can you see Now in Android?
Yes.
Yes.
Okay, so if you look at this app by Google, so what they did is they modularized by both feature and layer. So we have our default app that we had on our app, so that has the main activity and also has the Hilt application. Then we have different modules. So in this case, we have a features module, then we have the core module. Then within this core is where they have defined the business logic. So we have the code that you'd write for data, then the code that you'd write for the domain layer is under the domain module. Then every model that they have within this app is defined in this model package module, that is. Then the UIs, they have added them within the features, such that if we have a bookmarking feature, yes, so our composables would be within here. So this is the screen, this is the composable screen. Then for the interest composables, the screen, these are the and I mean, this is where they are positioned. So you can separate that by modularizing, or even, as we mentioned, by doing it within the same app but having different packages.
I see. Is it the open source application that I can just look how it's organized, or it's your own?
No, this is open source. It's let me just look.
Can you please share? I just
Yeah.
Thank you.
Thank you so much. We have one last question. Luba asked, there is no navigation bar, follow button in Compose.
the navigation bar, sorry, there's no navigation bar in.
Flow button in Compose. Maybe she can like explain her question better
Yeah.
if she can unmute herself.
So we're just curious, so I can Google if we don't have time for answer. I used to use the flow button for adding, for instance, something in
Oh, the
navigation bar.
action button. What do you mean by flow button, or do you mean the floating action?
Flow button is just in the end and right corner of the screen, for instance. There's just circle, and
Yeah.
this button is just stick on this place. And if you would like to add for instance, to-do list, you just press this button and you can add something.
Oh, yeah, it's still there. However, it's just like the card, it's a material tree or material, it's a Google's component on their design system. So, but you can still use it as long as you have the material tree API implemented within the app. So like, for example, if I came here and I wanted to add a floating action button, it's still, just to answer your question, we still have all
Okay.
material tree components, just that maybe some of them might not be created, but the ones that you have specifically asked are, we have them already. Yeah.
Okay, thank you. It's an interesting topic. A lot of questions I have. Thank you very much.
You're welcome.
I think we clear all the questions, and also we are really like past our ending time. So thank you, Jane, for answering all of our questions, and thank you for this amazing session. I just want to add something, like if you are not part of our channel in the Slack, please make sure to like attend the Understudy Club channel, and we are posting like bi-weekly notes there. Right now, we are focusing on Android basics with Compose, and after that, we will follow up with another Compose series from Google. And thank you all for attending and participating. This is really one of the best sessions we had. So also thank you again for Jane. We are recorded this session, so you can access it through YouTube. When we post it to YouTube, I will also let you know in the channel.